Before I am going to Dr. Paromita Chakraborty, actually the team from UAE side, they have requested, can they have like 5 to 10 minutes to express their their status of NIP. So I am giving the floor to UAE. So I think they are on the queue. So anybody from UAE side? Hello. Otaiba, Dr. Otaiba, are you there? Okay, he's not responding. And then I think we can start with Dr. Paromita. If he is available after Dr. Paromita, he can give their presentation from the UAE side. So the next talk will be an overview of electronic waste and inventories of polybrominated diphenyl ethers and other flame retardants based on Stockholm obligation. Before I am giving the floor to Dr. Paromita, I will give a brief introduction about Dr. Paromita Chakraborty. She is an associate professor at SRM University, India, and Chakraborty leads the Environmental Science and Technology Research Group. He is intensively working on fate, transport, and remediation of legacy and emerging contaminant. And she has various collaboration, and she has like enormous number of publications and book chapters and more than 2000 citation, and as of an H index of 26. Okay, Dr. Chakraborty also hosts a fellowship and internship for students from national and international institute as well. So Dr. Paromita, now I am giving the floor for you. Please go ahead.
Thank you, Dr. Yasser. This is really a big opportunity for me to present our work here. And I would like to thank Dr. Hassan for the invitation. And thank you very much for giving me this floor today. As a part of, we are also part of this special directorate of POP Center here in India. So it would be a really good networking place for all of us, I guess. In the outline of my work, first of all, I will introduce like what is the electronic waste status, why I'm highlighting the developing world and why it is the global scenario, what is the global scenario, and in what association we have the flame retardants with the electronic gadgets, and coming to the Stockholm Convention, the inventorization process, and a small case study from South Asia, that's from India, which might be helpful for for all the Middle East countries. Possibly one case study can be very interesting. So coming to the status of electronic waste and the flame retardants, if you look into this, what are the products that brings in prominent flame retardants? That could be several. It can come from mostly the plastic casings where a lot of flame retardants are being used. In this regard, like I'm not getting into different types of materials that can have the flame retardants. Rather, I would be focusing more on the electronic gadgets or the waste out of the electronic waste. And if you look into this table, like it's interesting to understand that different type of polymeric materials, say for example, for instance, the computer casings or the TV case, a lot of flame retardants would be used. And many a times, like, it is associated with the plastic. There is an interlinkage between the plastic component and the flame retardant that is being added. So there are several types of POPs, not just alone flame retardants, but it could be PCBs, it could be even dioxins, purans, when it is like openly burnt, a lot of materials end up in the open dump sites, especially in the developing economy. All those could add more to the story, like what sort of persistent organic pollutants are getting added up. So what is this basically electronic waste? We all know, we all are using gadgets all the time. We are changing gadgets like anything. But what happens like when a good quantity of electronic waste is coming into the market? That is not an easy thing to handle. And the growth of the electronic gadgets, the production would be increasing. It won't be decreasing anyway. So with our demands, it is going to increase, and 80% of this volume of this waste is made up of metal and plastic. We have to focus on the mostly, like, say, for example, the printed circuit boards or CRTs, cathode ray tubes, where a lot of chemicals, especially the flame retardants, are being used. Now, what happens in the developing economies, many a times this end up in the waste streams. Waste streams may a very well designed waste stream, like a landfill site, or sometimes it may not be a very formal sector. It may be taken care by the informal sector, which is very, very important and essential to understand. Now, looking into if you look into different kind of chemical, different kind of electronic devices, you see here, like starting from the keyboards or the cell phones or the computers, quite a good quantity is made up of the plastic. Why I'm emphasizing on the plastics? In the first slide, I showed that, for example, high impact polystyrene, the casing part, or even ABS, different kind of plastic materials, the polymeric materials, a lot of flame retardants are being used. Either they are chemically binded, or sometimes it is just like a plasticizer where it is overlying between the polymeric materials, not chemically attached. That's how it is important to understand, like, what are the different materials, where we can expect this kind of chemicals. If you look into the global scenario, something very important I felt, like the quanta of electronic waste that is being generated. When it comes to Western Asia, actually the generation amount is much lesser when it compares with Eastern Asia or Southern Asia as well. Eastern Asia is the maximum, like with China topping the lead. But then again, coming to Western Asia, like Turkey, Saudi Arabia, Iraq, like their per capita production of electronic is pretty high. But again, comparatively, Central Asia is way less, the least. And Southeastern Asia or Eastern Asia, or matter of fact, Eastern Asia is the maximum one in terms of generation of electronic waste. Now, it is not only the amount that is being generated within the country, the domestic waste, but many of these Asian countries or even African nations are getting waste from the developed world. Now, this is an interesting part, like where the major e-waste that is being produced in EU or United States or even in Australia, major chunk of the electronic waste that comes earlier, it was to come to China, like 2018, January, China made a strict ban of taking up this waste because of a lot of such chemicals, including the flame retardants, are ending up in the environment of those countries where they are recycling it. But this map shows a very interesting points, including cities in India, in Africa, and in China, like that, where major chunk of this electronic waste is being recycled. Now, why they are coming here for recycling in these countries? It is because of the cheap labor. Because in the developing world, it's easy to get and the rules are not so stringent as it is in the developed world. So there are certain leakages. If you see, the major producing chunk are the developed world, where good quantity is being used. There is a known source, and there is a suspected destination where it is coming up. In the suspected destination, India, China, as I was telling you, like, was one of the major chunk, and now other Asian countries like India, Pakistan, Bangladesh, and even Vietnam, these countries are taking up a lot of good quantity of electronic waste, and which again, like, which has an attachment, like a lot of chemicals, unwanted chemicals are also ending up in these countries, in this part of the world. And it is to be noted that this waste that is coming in or domestically generated, these waste are being recycled not by the formal sector. It is recycled by the informal sector. More than 90% of this waste is being recycled by the informal sector, because it is a big job opportunity. A lot of people can be involved. And more than the ore, like, why people are aiming at this waste? Because of the precious metals inside the this electronic wastes. The precious metals like copper, silver, gold, it is more fascinating to extract, or more cost effective to extract the gold from electronic waste compared to an iron ore, because it is already in a good form. It is much more in a neat form to extract it from this kind of waste material. So which is why this is very, very important. It's kind of, it says like an, urban mining. It's a very neat mining because you are not taking it from a crude ore, but taking it from a clear, neat source. So what we tried to do a survey, and what we found is this recycling process takes place in varied steps. And when it takes place, we have to understand what are the steps, what are the activity phase that is taking place. Based on those steps, a lot of expected toxicants can come out. And these toxicants also include a lot of flame retardants. Now, the first stage doesn't show much, like the dismantling stage, when the electronic waste are taken in one place and dismantling is taking place, or even segregation is taking place. But there are phases where pyrolysis is taking place, where the cable wires are removed and metal is recovered. Those are the sites where more amount of toxicants, a lot of flame retardants, a lot of flame retardants added as a phthalates, which are basically the plastic additives added to the plastic component. And when these plastics are burned to bring out those metals, that becomes an important point to be noted. Like these becomes a primary source for many such persistent organic pollutants that comes under the Stockholm Convention, including a good quantity of PBDEs or other flame retardants. And then another thing is, some of this waste material which are coming from the precious metal recovery sites or pyrolytic sites, these are ending up in the open dump sites. If they're ending up in the open dump sites, again, their incomplete combustion is leading to atmospheric emission of a lot of these compounds. And as we know, these compounds are semi-volatile in nature. So it might have a severe impact in the environment. So what are these chemicals we are associating with, and what the obligations we have in the Stockholm Convention regarding this? Now look at the criteria of the flame retardant chemicals. It is many in number. Thousands of such chemicals are there. But those thousands of chemicals are not coming under the Stockholm Convention. That has to be remembered. So these flame retardants can be halogenated phosphorus types, or metal hydroxides or carbonates types, or char forming types. Then the main flame retardants, which comes under the halogen containing flame retardants, like mostly the BFRs, brominated flame retardants. Those are the ones which actually come into the Stockholm Convention's criteria, and they can be of varied types, like some of the legacy brominated flame retardants, like polybrominated diphenyl ethers or hexabromocyclododecane, tetrabromobisphenol A. So these are the legacy ones. And then again, we have those, the novel brominated flame retardants. Those are also contributing quite a good number. And these novel flame retardants are still being used. And we see that in 2009, like this party's, the Stockholm Convention on POPs added brominated flame retardants in admixture-A, like it is needed for complete elimination of those compounds. So halogenated flame retardants are the ones that would be more important or interesting in terms of electronic waste in particular. The quantity of production of this PBDEs were like maximum, if you see, was in China or in other Asian countries, and to a certain extent in US and Israel as well. And as time passed on, like there are bans on certain chemicals, so they are coming to an end as well. But still, due to persistence or due to some of the old gadgets, it's still there in the many other countries. Now, if you look into this figure, like wherein the estimated regional consumption of especially DECA-BD, which has been banned like now, but it was extensively produced and used. And if you see, mostly it was in Asia. So the production units, what I mean, it's not just the waste part, but also from the production part, that was also important to understand. So a lot of this commercial penta, DECA or octa BDs or other BDs, a good quantity is still there in the electronic gadgets, especially if you think about the heavier molecules like the octa BDs, commercially octa BDs. So in electronic gadgets, which is a good quantity, but if the number is more, see, for the construction or transportation or textile, this doesn't come out from other countries to this developing world or other part of the country. But electronic waste quantity is too high. So even if the composition of the quantity is less, but it can be very, very important. Now, if you see that hexabromobiphenyl, what is the status? Like in what way these compounds are there, or what are the restrictions that has come up? Of course, European Union has taken very good action in most of these compounds. But if you see, like in US, there is no federal restrictions for HBB, and China also no serious regulations are there. And India has tried to ban, but it is still through the electronic waste or different other electronic gadgets it's coming in the market. But other than European Union, the other part of the world, like they are still yet to control HBB. That is the one important point, one type of this brominated flame retardant. Now for PBDEs also it is similar. Again, European Union has taken really very good strict actions on PBDEs as well. And China in this regard has set like India also, both India, China, they have set the concentration limits for penta and octa BDEs when they're manufacturing new products. So that is again the manufacturing unit, as I said, like most part is there in Asia. So that is again important. India has banned certain trade and use of this for penta and octa BDEs. But like really, I mean, how strict is the ban? That is still a question. And US again, PBDEs also there is no federal restriction as per the reports are saying. And for hexabromocyclododecane also, like it's the same story as PBDEs, where China and India has taken some strict action other than a very strict control by the European Union. And comparing with the other parts of the world, like of course this again depends on the production part and also the manufacturing units, which are mostly there in these countries. And even not only it's just United States, but also like South America or Japan, this are yet to be, means it's still in the progress, like the regulations are limited. So when this production comes, like production or manufacturing process comes, that is where also the emission can take place for different sort of PBDEs. So there again, you see that in the environment, it can get into the different strata of the environment. It can get into the atmosphere, it can get it land, it can get into the hydrosphere, in water bodies. And because again, it's being semi-volatile, it can also be transported, as the previous speaker, Dr. Said, like that there can be the long-range atmospheric transport, which is again a very important phenomena for us to understand, like the atmospheric transport. And if you see here, one important component is not just dumping or like improper or not well-managed incineration processes, which are there in practice in economy. Open burning of electronic waste is also another thing, which we have also seen in a lot of papers we have come out, like how this kind of toxicants are coming out in the nature. So all these compounds, as we like this Stockholm Convention is taking care of all this, which are coming under the persistent organic pollutants criteria. This again depends in a particular matrix how much it will stay back. Like what is the half-life of this particular molecule in different matrices, based on which the persistence will depend. And again, not only that, not only the half-life is an important factor, but also the bioconcentration factor is important, because these are lipophilic compounds. They can get into the lipid tissues of the body and then can have a serious health impact. And these compounds, again, as I was telling, that they are semi-volatile in nature, they can undergo long-range atmospheric transport and can impact somewhere where it is not being used. And these chemicals has a very difficult functioning of mimicking the hormones. So because they have, a lot of them have the endocrine disruption potentials. These chemicals are very important, which is why Stockholm Convention is taking serious action on these chemicals. So what we see here is like mostly this, there is this PBDEs, the global distribution. It has been taken from an interesting paper by Ho et al. If you see here, like the different matrices, it is showing in the water, surface water. The first figure is on surface water, global picture, the distribution of different noble brominated flame retardants. Now, if you see the dates, like this is again important, like the enforcement of all the different countries have taken it up based on the annexure A, B, C in Stockholm Convention, that most of the electronic waste or textile producing states are included here. So some are availing the exemption, and if you see, like some are availing the exemption, but they're still availing an exemption pursuant to the production of this chemical. So it is, one is the waste component, another is the production unit, which is also has to be taken care when we are preparing a national implementation plan. So how do we do this? How do we prepare this inventory? So here, like little bit brief summary, there is a Stockholm Convention report. With I took that help of this report to understand like how to explain this part. So the planning inventory means we have to establish a national inventory, like which is very much needed at this stage, because for any country, that matter of fact. And how do we do that? That one is we have to develop this inventory system team to understand where are these chemicals, what is the strategy, like what quantity we are getting in. We have to identify the key stakeholders, which not only, again, I'm telling, not only associated with the waste, but also with the manufacturing units, and define the scope of the inventory and develop a concrete work plan to do this process. So first step is the planning this inventory. Second would be definitely the data collection. The methodologies of data collection are based on 3 tiers. I'm coming to it in the next slide. Then after we have planned the inventory and we have chosen the data collection techniques, then we can go for the collecting and compiling those data sets. And that would include electronics waste that is in use or in recycling or for storage capacity, whichever way. Transport sector, a lot of end-of-life vehicles, there are a lot of electronic materials used, but it's not just electronic waste inventory or NIP. When we are preparing, we need to consider all sort of products that can have this kind of contaminants. So in that case, the other uses, say for example, the furniture or textile materials, wherever it is being used should be considered. So that is the collection of those data. And then to identify the contaminated sites, definitely these require a lot of monitoring, lot of national level monitoring, localized monitoring. So this so that we have genuine data. And then finally, we have to like manage or handle the data before we prepare the inventory report. Now, I would like to explain this tiered approach process, which is again part of the same resource, like which is part of the Stockholm Convention details, like which I have taken the help of that, prepared by that NEET program. So here we can involve 3 tiers. One is the initial assessment. Initial assessment means you can meet, you can have a survey, you can have a discussion, you can have interviews or questionnaires sent out. And then that is an initial assessment to understand what is the strategy, what is the status. That's just like mostly that site investigation for how we do it. Then a preliminary inventory, the tier 2. It involves like some sort of surveys, and we have to go to the site. Now, no more questioning, but going to the sites, understanding what is happening at the sites, and how do we assess. So that would be like whatever we have got from tier 1, we are going to extrapolate it in tier 2. Now, tier 3, which is an in-depth inventory, here definitely we need a lot of good analytical skills, because we have to get into the site, we have to understand what is the site all about, what are the materials to be taken, and we have to do a lot of monitoring or even flux estimations, a lot of work, which will be involving a lot of instrumentation, like the previous speaker mentioned about, like MSMS or high resolution mass spec for different sort of compounds and what quantity we may be getting. So those kind of instrumentation facilities are also required to go for this the tier 3 inventory. So this is again another important factor that has to be kept in mind while we are preparing this inventory. So with this, I would like to come to directly to this a small case study that we have, so that it helps to understand. And also maybe when you're preparing the NEEP, I felt that it is essential, like some cost-effective monitoring techniques should be there, which is why I have evolved, like apart from the inventory designing, like how do we go about some sort of monitoring. Now, as again, coming back in terms of, we started with electronic waste. So again, electronic waste in this regard, what we had been doing. See, as I told earlier also, this is from Basel Convention network in talking about, like it's a bit earlier picture, but a lot of quantity of electronic waste coming to the Asian countries, especially earlier it was China, and now more on other South Asian countries, including India. And this, if you see that overall production, domestic production is also pretty high for these countries. And in India, I'll give you this case study because it's from India, so I want to mention this. The 5 major cities, Mumbai, New Delhi, Bangalore, Chennai, and Kolkata, these are producing actually the major chunk of electronic in the domestic. Also, they are involved in recycling. Delhi is the main hub for recycling electronic waste in India, that is coming from other countries as well. So we have tried to get into all these cities and understand what is the story going on and how do we come out with source types. So this sites, mostly it is taking place by the informal e-waste recycling process. And wherever you see here, this is a global map, like where it was modeled. One PCB container was modeled, PCB 150. If you see reddish zone, this areas is like where high temperatures. These are the areas having high temperature. So, which is also a suggestion for, I think, West Asia as well. Like high temperature can lead to higher emission of these compounds. So it is very, very essential to start a monitoring, the atmospheric monitoring. So in the developing world, there are a lot of such monitoring based on the electronic waste. Associated emission of a lot of chemicals were there. And this is one interesting story where we could pull out, like this was the best policy paper runners-up. It won the runners-up award in 2011, wherein we were trying to say like that reduction of a lot of these chemicals, including flame retardants, in the developed region. Is it could be because these are being sent to the developing world? So that is a very important question that led to a lot of inbuilt research in the near future. So we catered to, as I told you, all the 5 Indian cities, and we found that the metal recovery sites or the open burning dump sites, these are the areas where more quanta of lot of chemicals, including even dioxins, furans, especially furans, acid leaching sites, were very highly prevalent. So to understand this factor, like as Stockholm Convention and UNEP, like both wants a lot of data, a lot of monitored data, and air is a very, very important media because of this semi-volatile organic compounds would be there more, the emission would be there from different sources. So it's very much essential. And this also helps or supports to prepare the need for every country at the national basis. These are the legacy POPs, the new POPs that are there now in our ministry. We don't have all the POPs in Indian Ministry of Environment, Forest and Climate Change website. So we were targeting most of this, mostly in the air. Now, this is a very, very cost-effective sampling device. I wanted to mention this so that if there is any possibility, we can collaborate. If anything, any assistance is required, like with my whatever minimum knowledge I have, I would be really happy to help out. But this, I mean, this is a very good device that Environment Canada and GAPS started coming up with Tom Hanna, Sir Kevin. Like this has been extensively used across the globe. And the cost of this sampler is so cheap. It's made up of 2 steel balls and with the polyurethane plug in the between, and can be a very, very easy to manufacture also. It has been, as I told you, it has been used across the globe, and by these big groups, they have come up with not only limited only to developed regions, but different temperature zones. These passive samplers have been used. And at one point of time, it became a very, very important factor that it was in 2008, it came in ESNT news that it's one of the cost-effective sampling device that can be used for different parts. But not only that, in developed nations also, they have used it for global atmospheric passive sampling study. And it had been going on nearly 10 years or more than a decade now, and giving a lot of inbuilt informations like, quick informations, because you can deploy it, you don't need an electricity, you can deploy it all over, and a spatial mapping, a temporal mapping can be quickly obtained. And that ultimately, for Stockholm Convention, this kind of monitoring actually became very, very important. So we used it like for the coastal length of India, and we found the urban tilt. The metro cities were the major sources for mostly the polyvoted diphenyl ethers. And this metro cities, we saw this in the initial, in the 2008 this reports we were seeing. Then we went inside to the metro cities. As I told you, these are the major cities producing major chunk of electronic waste. What we found was a very hotspot region. See, this is how you can plan urban, suburban, rural transit. You can deploy the device everywhere, and it is so cost effective. We can get to know where is the hotspot. We can do even more high volume sampling there, but initially we can understand where is the hotspot. And these are the areas. You see the difference between the levels were over 20 folds. And these are the sites which were associated with informal e-waste recycling or to some extent open burning. So that made us understand this is again going to be a very important source for these compounds. Now we have quite amount of data to do a time trend. And again, we use the passive sampling device. This is a paper from this year, ASNP, that we are seeing that the BDE47, which is quite a ubiquitous congener of BDE, these you see it has increased since 2007 to 2020. Even though now people are telling that atmospheric concentrations or atmospheric observations are the air quality is improving, but it may not be the case for persistent organic pollutants. So we have to pay attention to that, and we are working on this. And it's an important story, even in 2020, we are seeing this. So you can utilize this passive sampling device as an important device for future studies. And a lot of atmospheric modeling shows if the cities are coastal cities, how much is the residence time for the air parcel. Mostly the inland cities like Bangalore, where the air parcel could be, or New Delhi especially, the air parcel, the time of air parcel retaining in a site is more. So which means the exposure from those compounds, from such kind of semi-volatile compounds would be more. So such a monitoring or modeling work can be carried out in all the countries across Asia, and that could be giving rise to a lot of good information that would be beneficial to prepare your NEET programs. I would like to acknowledge our project, which helped me to prepare the status report on PBDEs, and we are working this work. What are the slide I showed you that PBD output, like the retardants that we are working on. And with this, I would like to thank all of you for listening to me. I hope I was on time, and thank you very much once again for the opportunity. And I'm open to any questions, very open to collaboration, and whichever way we can work out most of it. Thank you.
Thank you so much, Dr. Paromita. It was a wonderful and excellent talk. So I am opening the floor for discussion. So please, you can, because Paromita is ready to help. Yes, Roland, please.
Yeah, Paromita, thank you for the very interesting presentation. One question for the production of brominated flame retardants in India. I think there is production. Do you know what kind of brominated flame retardants are produced, and which main novel brominated flame retardants you find in India?
I think a very difficult question for me to answer. Yeah. I wouldn't say I know all of it, because we actually do not have a lot of information like what we are producing actually. So that inventorization part is still not clear. But what we found is there is some contamination of bromcal, like for penta-PBDEs. There were some production which was used for a lot of plastic materials for the production of plastic goods. Exact number I won't be able to tell you, because we don't really have quantity inventorized somewhere. So definitely the penta and deca BD, that production, there are few articles on that deca BD production was there, but it has been banned now as per the Ministry of Environment, Forest and Climate Change. But still, again, our recent work, which we have not published yet, that we are seeing that deca BD is still, maybe because of its persistence, that we are still seeing very high. And in our new data, we are seeing even a lot of octa-congeners are also pretty much prevalent in some of these industrial sites. Especially, we have a huge plastic manufacturing belt in western part of India, which is part of this project basically. So we are able to figure out so we are not able to tap what is the quantity we are producing, but even some of the octa formulations which can be used in a mixed way, that could be a possibility.
Yeah, I mean, in China, what I like is that they are doing monitoring around the production side.
Yes.
I mean, really the production side of the brominated or chlorinated flame retardants. So, because normally for brominated flame retardants, there are most likely not many facilities. So I don't know if you know how many facilities are there, and if you have considered to do some monitoring there, because I think this would make it more clear what flame retardants are at the moment produced or which were major produced.
Yeah, that's actually what we are trying to look at now, because unlike China, if you see papers from India are pretty much limited. We don't do that regularized monitoring, and this is one set of monitoring we did during the COVID-19 lockdown phase. So this was after the second wave of COVID-19, and we tried to monitor some of the production unit areas. So which is why the passive sampler was very useful. So we have those data now, which is why I'm able to tell you that some of the octa-congeners, which is very strange, and we see a very distinct profile between the typical industrial sites and the sites which are involved in informal e-waste recycling. So possibly we need, this may lead to a lot of more information, and we need to inventorize that, which unfortunately, like China, we do not have much data. Yeah.
Yeah, no, very good. I mean, 5 or 7 years ago, I saw a study from the group of Harner, which did a global air monitoring. And then I think in India, they had some peaks on hexabromobenzene, yeah, which for the chlorinated compound is in the Stockholm Convention, right? But the hexabromobenzene is not restricted yet.
Yes, it's not, and we have not included all of these compounds in the as the new POPs list. If you see, we have only included 7 such, which includes mostly the BD congeners, but not any other compounds, and it also includes HBCD, HCPD, few other, and I think one more compound, chlorododecan. Other than that, we have not included, and few of the pesticides we were actually using. So other than the 7 new POPs, we have not included those in our priority list now. So possibly if we monitor and we get those levels, it might be a reason for the ministry to take it up and come up with new strategies.
Yeah, thank you, Paromita.
Thank you.
Thank you, Roland, and thank you, Paromita. So if anybody has any clarification. Yeah, I think nobody is raising their hand or they are not inviting. Okay, once more, thank you so much, Paromita, for your wonderful talk. Yeah, and now I am giving the floor to Dr. Hassan.
Hello, hi, Yasser.
Yes.
Thanks all for all who submitted their presentation. especially for Paromita and also Dr. Roland. He given some question which is really important. Hopefully we'll see you tomorrow, inshallah. And at the same time, I think it will be 9 o'clock. And we'll see you tomorrow, inshallah. Thanks all of you. And we'll see you tomorrow. Thanks. See you.
Okay,
Bye.
thank you so much, and goodbye to all.
Thanks.